You have looked at the sky thousands of times on the way to school. From a car window on a beach, lying on your back with nothing else to look at. You have looked at the sky more times than you can count, and every single time it has been blue. That feels obvious. The sky is blue. That's just what it is, except it isn't. The physics that governs how light behaves in the atmosphere does not produce blue. It produces violet. The sky should be violet, a deep, saturated violet that you would see every time you looked up. The math is clear, the science is settled, and if you ran the numbers without knowing what the actual sky looks like, violet is exactly what you would predict. But you have never seen a violet sky in your life, and neither has anyone else. The reason has nothing to do with the atmosphere, the sun, or the way light scatters. It has to do with you. With your eyes, with a quirk of human biology so specific and so invisible that most people go their entire lives without ever knowing it exists. And once you understand it, you will never look up the same way again. To understand what is actually happening, you need to understand how light works for about 30 seconds. Sunlight looks white, but it isn't. It is a mix of every color in the visible spectrum packed together. Red, orange, yellow, green, blue, indigo, violet, all traveling together until something separates them. When sunlight enters the Earth's atmosphere, it collides with the tiny gas molecules that make up the air. And when light hits those molecules, it scatters. It bounces off in all directions, but not all colors scatter equally. This is the part that changes everything. Shorter wavelengths of light, the colors toward the violet end of the spectrum, scatter far more than longer wavelengths like red or orange. Specifically, violet light scatters roughly 10 times more than red light when it hits an atmospheric molecule. This effect has a name. Lord Rayleigh described it mathematically in 1871, and it has been called Rayleigh scattering ever since. Because of it, scattered light fills the entire sky and gives it a color. And the color that scatters the most, the color that should dominate the sky based purely on physics, is not blue. It is violet. So why do you see blue? That is where the story stops being about physics and starts being about something much harder to study. The human eye does not work the way most people think it does. Your eye contains 3 types of color receptors called cone cells. Each one is sensitive to a different range of wavelengths. One type responds most strongly to red light, one to green, one to blue. There is no cone cell specifically tuned to violet. Violet light does stimulate your blue cones, but it also weakly stimulates your red cones at the same time, and your brain, receiving signals from both, interprets that combination not as a pure violet, but as something closer to blue, a shifted, desaturated blue. This is not a malfunction. It is just how human color vision evolved. The system works extraordinarily well for the range of colors that matter most for survival. Distinguishing ripe fruit, reading shadows, recognizing faces, violet at the far edge of the visible spectrum was never a priority. But it means your eye is genuinely bad at distinguishing blue from violet when violet is spread across the entire sky at relatively low intensity. Which is exactly what happens with scattered skylight. And there is one more factor on top of that, the one almost no explanation ever includes. The sun itself is not neutral. Sunlight contains significantly less violet light than blue light to begin with. The sun's spectrum peaks in the yellow-green range, and the atmosphere absorbs some violet before it even has a chance to scatter. So the sky is being lit by a source that already has less violet in it than the physics alone would suggest. 2 factors. One biological, one solar, both pointing away from violet and toward blue. Together they are why you have never seen the sky that the physics of light would predict. Here is the number that makes this real. Violet light has a wavelength of roughly 380 to 450 nanometers. Blue light sits just above it, between 450 and 490 nanometers. The difference between the two is less than 70 nanometers, less than the width of a single bacterium. That gap, smaller than anything you could see under a standard microscope, is the difference between the sky you see every day and the sky you would see if your eyes worked slightly differently. Bees can see ultraviolet light, which sits just below violet on the spectrum. When researchers photograph flowers using ultraviolet cameras, the images look completely alien, patterns invisible to human eyes that guide insects toward nectar. The flower you see and the flower a bee sees are not the same object. Mantis shrimp have 16 types of color receptors. Humans have 3. A mantis shrimp looking at a sunset sees a visual experience so far beyond human color perception that there is no meaningful way to describe it in words. And the sky, the same sky every human being has ever looked at. The sky that artists have painted for thousands of years is not the color it actually is. It is the color your particular set of 3 cone cells, shaped by millions of years of evolution, for reasons that have nothing to do with atmospheric optics, decided to show you. The sky is blue because you are human. That is the only reason. For most of human history, no one had any explanation for why the sky was blue. It was simply accepted. Leonardo da Vinci wrote about it in his notebooks in the late 1400s, describing the blueness of the sky as darkness seen through illuminated air, an observation that was poetic and partially correct, but had no mathematical foundation. René Descartes attempted an explanation in the 1630s. Isaac Newton described how prisms split white light into colors in the 1660s, but did not explain the sky. For 2 centuries after Newton, one of the most fundamental visual facts of daily human experience remained without a rigorous scientific answer. It was Lord Rayleigh who finally provided the complete mathematical description in 1871. A formula that explained not just that the sky is blue, but exactly how blue it should be and why. What that formula could not explain, and what scientists debated for decades afterward, was why the sky was not even more violet than blue, given that violet scatters more strongly by every measure the math could produce. The answer required combining atmospheric physics, solar spectroscopy, and human visual neuroscience into a single explanation. 3 separate fields, 3 separate lines of research, all pointing to the same conclusion. The sky is not the color the physics produces, it is the color the physics produces, filtered through eyes that were never designed to see it accurately. If you take the human eye out of the equation entirely, the sky stops being blue. On Mars, the sky is a dusty pinkish tan, not because Martian sunlight behaves differently, but because the fine iron oxide dust particles in the thin Martian atmosphere scatter light in a completely different way. NASA's rovers have photographed it. The color is unmistakable. At sunset on Earth, the sky turns red and orange because sunlight at that angle travels through so much more atmosphere that most of the blue and violet has already scattered away before it reaches you. Only the long wavelength reds and oranges survive the journey. Every sky color in the universe is the product of a specific combination of star, atmosphere, and observer. Change any one of those 3 variables and the sky changes with it. Blue sky. The blue sky you have seen every day of your life. The blue sky that feels like one of the most permanent and fixed features of the physical world is not a property of the atmosphere. It is not even a property of light. It is a property of you. A shift of 70 nanometers, smaller than a bacterium, invisible to every instrument you own, and it is the difference between the sky you see and the sky that is actually there. First, it was a mystery that Leonardo da Vinci wrote about and could not solve. Then it was a mathematical formula that Lord Rayleigh spent years developing to explain why light scatters the way it does. Today, it is the color you see every time you look up, not knowing that your eyes decided it for you long before you were born. If this video changed the way you see something as permanent as the color of the sky, subscribe. On this channel, the things that seem most obvious are always the ones hiding the most unexpected explanations. And the next video is going to show you exactly that.